Okay, hi guys. So what we're doing with this particular citizen science project, our um, group project that you might be working on in your class, is just to record the number of minis, spontaneous events that occur after an evoked stimulation. So some of the other movies or background information that's on this web page. This is the Citizen Science webpage. You can find it by going to Cooper's homepage. Just write Robin Cooper, and then you can scroll on down, and you can go to the Citizen Science page right there. You'll have this information. If you should already have the general background that we've already given about this project. Part of this class has worked on this project, freshman class at the University of Kentucky. And here's some information that you can download and understand some of the content. The measures that Tori mentioned in here about the details of using the software are cover many different topics, but for us, our purposes, we're just going to count the minis. So this video, I'll put a new one here about just counting videos by Robin. That's me. Okay, so here are the files to download. You'll need to download this file and a data sheet, and then you want to save it under your name so you can send it later. And this makes it really easy, this Excel data sheet, which looks like this basically. It has the file name, and I'll go over this. This is the frequency being measured in the trial number. These are the bins that we're going to divide up the stimulus in. The traces that we're recording, we're dividing them up into half-second bins and counting the number of spontaneous events. And then you can add a comment here like what time did you start on the file. You'll see at the time stamp where you want to begin maybe your time period. Maybe it won't exactly be 0 because it's a continuous time. Okay, and then we keep doing that until we get to, let's scroll on down here, every 30 seconds about. So now we have 30 seconds, and we see this is trial number 5. There's multiple trials. This is recording. There are multiple trials here, so we will go through, we're just going to collect trial 1 and trial 5 and trial 10. And you see each one divided up into 30 seconds. And then comes the 40 hertz trial, trial 1, 40 hertz trial 5, and 40 hertz trial 10. And then we see a 60 hertz trial, trial 1, trial 5, and trial 10. So there's 10 trials. Whoops, let me go. 10 trials. And it also goes to 30. I'm not sure if we'll get to 30 on every one of them. Okay, and so we're going to count the number of minis in there and write it in here. So I would suggest saving this data sheet, putting your name on it, and then we will try to assign a particular trial that needs to be analyzed and which frequency. So the goal here is to see what people get by the number of minis in trial 1, trial 5, and trial 10 for the 20 hertz, 40 hertz, and 60 hertz stimulation. Now, what do we mean by these 20 hertz trials? We stimulated the nerve terminal at 20 hertz, and then we turned it off, and then we look at the number of minis. And then we stimulated it at 40 hertz, and then turned it off, and we look at the number of minis. And the same idea at 60 hertz, and we look at the number of minis. The idea is that increased calcium loading in the nerve terminal will then increase the number of minis right after the stopping of the stimulation. So this is what we're hoping to look at. So there's that, and you want to download this file, your data sheet for the Excel sheet, and depending on which file you're going to analyze. And then there's one other file over here. This is a half or 0.1 millimolar calcium, where up here it was a 1 millimolar calcium. That's normal. So a low calcium and a high calcium, that's the two data files that we're going to analyze. We've already analyzed with 9 different people the stimulations Let me think here for a second. Yeah, we've already analyzed this other project, not this one. This other project that it's not on here anymore. It's this file for calcium responses with optogenetics. Okay, so let's look at the files, what we have to do. Now what you have to do is you have to download LabChart Reader, unless you're already using ADI Instruments. So you go to LabChart Reader, and you will see this is freeware. So you download this freeware, and it will allow you to open the file that we need to look at. So the file, MyChart software is going to be a little bit different because this is the bought version. But you will see something like this. So you open up your file. See, my computer's a little slow. And now we can open our file. Let me see if I found it. I put it on my desktop. And let's look at this one. It's called 30 seconds interval 117-17. So I'm going to click on that. Then you see this chaos. So if we might have to adjust the screen here a little bit. Sometimes the software is a little bit odd, so you have to kind of decrease it and increase it to make it work right the way you want. Okay, it might even help just to write it down on paper. I don't know for sure, instead of just going back and forth with the Excel sheet. But you can see the stimulations here. Let's go through this file a little bit. So this is the beginning. What you have is a scroll bar down here at the bottom. And if we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's the 10 stimulations at 20 hertz. And if we keep on going this way, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there's 11th, but we cut it off. And then this is the 60 hertz. If you can't read these little files, you can kind of, I think sometimes maybe you'll be able to do it too. You can move them over a little bit like that. You can see this is 60 hertz. You can also, I think in your view, you'll be able to go up to comments and click on that, and it will tell you where the 20, 40, and 60 hertz starts, and you can click on it, and it will definitely go right there. So you might want to add in, I don't think, on the reader, on the free software, you can't add any comments, but you'll just have to keep track, like this is number 1. So what you do here is you enlarge this, you blacken that out, and you can go to the zoom window. There's the zoom window. You can see these are a lot of minis in here to count, but we want to divide it up into half-second bends right after the stimulation. So how to do this? Well, you can see your time up here, 24, let's see, if I keep my cursor right there, it says 22:98.76 seconds. So if I write that down, let me write that down somewhere. And 22:98.76. Let me get a pen. Okay. So I'm going to write this down. 22.9. Whoops, I hit the cursor. 98.76. Okay. So I could go over here and say the beginning of 0 will be 22.9876. You know, maybe it's better just to start at 23. I don't know. So let's see how far that would be. Maybe it'll be easier for us to do this. So let's go back over here. Where would 23 be? 23 is right there. So let's just do that. Okay, that's not too far off. But what we want to do is every half a second then. So it's 23.5. So you see we already passed a little bit. So it might be easier to blow up sections. So like this. And if you blow that up, you can scroll like this on the side. You can also do auto scale, and it will scale it for you, but sometimes it's too enlarged. And let's see what we can do out of this. So we said 23. There's 23. Now we want to count the number of minis. This is really a very difficult file, I think, because how to count the number of minis that are occurring in here. There are a lot of minis. If you want to zoom out, you can just go to Windows and go back to Chart View. And there we go. So let's see if we maybe get a little bigger spot. And let's do that. Zoom view. Okay. Now you see the minis a little bit better. Okay, so let's do this. And you can only do what you can practically do. So if I move my cursor, I'm trying to get right at 23. And then 23.5 goes to about there. But you see, you could think of this noise right here. This is noise. So what's a mini? This big event? Is that a mini there? Are these two? So sometimes it might be a little confusing. So I think taking some space, like maybe a second or two, and let's go to 25 so I can maybe get an even number here, or 25.5. There we go. You see, almost there. There's 25.5. Okay, so now let's count how many minis we might have here from 23. This is a fast rise and then a decay. This one's a big one in a decay. This is a big one. Is that 2 or is that noise? So if we're going to consider this noise in here, right here, then maybe that's just noise on the decay. And this is probably just noise on the decay. Let's think about this as noise right there. So superimpose that noise on top of your file. But a quantile event should have a fast rise and then a decay like this. So we could be a little conservative, or we could be more stringent and say we're only counting big events that are like 2 times the size of the noise. So if we see the noises from here to there, well, we want something then twice that size. We're only going to count those. Now let's look over here what the problem might be right here. Are these 3 events then? Because that's maybe about twice that noise coming through here. Is this an event right here? Is this one event, or is this a multitude of events? Is this 1, 2, 3, 4? But if we take that noise and kind of put it on top of this, I think that noise looks like that noise, and that noise is probably just noise there too. So what I'm going to do is I'm just going to count them like I might think only double of this noise. So let's go through this. 1, maybe 2 as the whole, 2, 3. So you see I only got 3 to 23.5. So I can make 23.5, 23.5, and I only got 3. Now 23.5 to 24. Right when if it hit it in its rise, we count it, but that one's kind of on the border. But let's count the next ones. So this might be 1, 2, difficult here, 3, and that one really didn't happen yet. So that one I'm just going to say 23.5 to 24 is 3. Now 24 to 24.5. 1, 2, 3, right on the edge again. I'll count that as 3. Now 24.5 to 25. 1, 2, fast rise, pretty big, but we didn't count it over there. But should we count it here? We could skip it, I guess, but we'll have to do that in all the others. So what do we have? 1, 2, 3. Is this going to be just 3 again? 3, and that's going to go to 25. Then we can go to 25.5, which is still here. So this is 1, 2, 3. I'm just going to count that as 3. 25.3. So we've got all 3s so far. Okay, now what we can do is you can't get out of that. You have to go back to the window and hit chart view. Okay, so we made it all the way to there. So if you have that little black spot, you can actually see where you are. And there, up here on the right, will tell you where the cursor is too when you move it. So right there is, 25.6. So we want it right like on 24.5. And then we can take another, we can take another bar or so. Okay, like that. Okay, and then hit zoom. And we already went to 25.5. So let's go 25.5 to 26. To 26. I just count 1 in there. You might count that something, but I wouldn't. And then 26.5, that's 1. 26.5, that's another 1. Get the idea? 26.5 to 27. Well, 1, 2, 3. That's really on the other side. So let's do 27 to 3. And then 27 to 27.5. 1, 2. Are we going to count this? Did we count that before? That rise? That's pretty good rise, isn't it? That's bigger than the little thing we did over there, I think. So let's do 1, 2, 3. See how it's a little bit off? It's the judgment call. Makes it a little hard. Oh, so that's 1, 2, 3. And this one's kind of started and it really fell in there. So that's really 4. Let's do that as 4 then. And then 27 to here. Well, we already counted that. So what do we got here? Maybe 1, 2. That one's after that. So we'll go to 28 as 2. 28 to 28.5. 1, 2. 28.5. 2. Okay, so you get the idea. Whew, I know it's hard. It's a lot. But, kind of, if you're over 21, you can get a beer and do this. And then if you're under 21, I don't know, get some water or some Coca-Cola or something. So this would be, the first one. And then we got 1, 2, 3, 4, 5. And then we want to count all these. And then we go down to number 10, which we count. And you count by the stimulation pulses. That's number 10. And if we enlarge the stimulation pulse, you can see what that was about. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 stimulations, 10 evoked stimulations. So that's what that is actually. And then you don't see the events up there because they're clipped off. But actually it's a synaptic response. Maybe somewhere, I think, maybe at the end of the file. No, we don't have any right there. So they're all cut off. And then we're just looking at these minis right after that. So we do the 1, we do the 1, 2, 3, 4, 5, and then we do the 10th one and counting those minis. Now, if we went back to that Excel file, we can say we started at 23. Okay, and then what did we do? We went 23. We could actually write in here if you wanted to 23.5, and we'll kind of know what's going on there. And what did we have? We had 3. I wrote it down on a piece of paper, 3, and then we had 3 again. We had 4 3s in a row actually, and return, and then we had another 3. So we actually had 4 3s in a row. And then we had a 1, a 3, a 4, a 2, a 2, and we made it all the way to, what was that number? 28.5. 28.5 is where we were. And you could fill this in if you want to, just so you can keep track of it. Otherwise you might, when you come back to it, you might forget which numbers you're actually on. So that was 23 to 23.5, and that's 25, and this is 25 to 5, 26. And then you always know it's in that half a second increment. Oops. Now, how'd that happen? Oh, you see, I would have screwed up that. So really it was to 28, right? What did I do wrong? Did I do something wrong? Could be 0.5, 0.5, 0.5, 0.5, 0.5. So I had a 1, 2, 3, 4, 5. Oh, I had 5 threes. 1, 2, 3, 4, 5. I need to insert. So you see how easy that is to mess it up? Maybe it's better to put the numbers in each time. 3. Now it's fitting. And the last number we had was 28.5. So now I'm going 28.5 to 29 will be my next count after I come back from doing this data. Then you want to, in case your file crashes, save as, and then you can save that to somewhere, and maybe your C drive, and write copy of data sheet, and I will write Robin here, and I'll try doing a count through there as well and see what happens. Whoops. Don't know what that means. I guess I'll just try that instead. That was weird. Isn't that weird? Okay. Anyways. And then you can do the next one, next one, next one. Okay, so I'm going to close out for now. Okay, do we get the idea with this? Don't know what this is about now. I don't want to do that. And if you look at the files, these are the files that we're analyzing. We have this high calcium, this low calcium. Right now we already have 2 people that counted all the way through here. So we're trying to get 2 people in every group. And we have 1 person through here. We have an N of 2 for all these. So what we're trying to do is to make sure we can get these counts. I don't know why this person that did this before, he counted the 6th trial, so it's going to mess us up. So we really need to kind of repeat this and do the 5th trial. So we need 2 people here, 2 people here, 2 people here. The 40 hertz, we need 2. We already have that one done. We need 2 people here. So that's 2, 4, 6, 8, 10, 11. Or maybe we can double count that. All right, and then we've already have all of these done and all of these done, so we're going to try to get these to be done. And I'll help out as well. So whatever you think a quantal event is, try to stay with it, and we'll try to assign, because otherwise everybody's repeating the same one, we'll try to assign some groups to this one, this one, and this one, maybe 2 people, so we have 2 different counts, and we'll compare those together, and then we'll get people involved here too. Okay, so what I mean, this is your first file. This is the 117-17. This other file right here is the one that's on the website, which is this one here, the 0.1, and it's still the 10-second pulses. So, okay, and we tried the 20 seconds. We didn't really see much difference there. But anyways, we're just going to analyze this one and this one. Here's your data sheet. You can use this and rename it for this one, because the name that's in the front of that data sheet is that one. All right. So rename it. Make sure you know which data sheet you're using. All right. So rename the data sheet there for this file. Okay. I think we're good. Let me know if you have any questions. This is really fun citizen type of science project, and what we're trying to do is to see how well we can do analysis online and how reproducible this is. We have some people that are interested in this in other countries and other places, so you're going to be participating in a large event, and if you want to know more about research articles or the type of recordings we're looking at, those are there. Here's some other kinds of recordings, a little bit different, that's explained in some of those papers. Anyways, have fun, and let me know if you have any problems when you finish your data sheet after we assign a few people with different ones. And then I'm going to take off the names so we don't, we're not worried about if somebody didn't quite match the others, but we want to go in and find out why there might be differences. And then we have a computer person that's actually going to look at the automated files and try to analyze this by an automated analysis and see if that's close to doing it by hand or how different it might be. And that way we can justify doing the automated analysis as well. Now you won't be able to do this in your files, but I'll just show you really quick. So we can actually choose three files here. I can make this a little bit smaller, and what we can do is to do some calculations, and I'll just show you what we're going to try to do with this. See how this can count the events, and let's say after that first stimulation, which is right here, we want to count all those events. So I need to spread this out. Oh yeah, and I forgot to tell you that you can spread out your file by going right here too, clicking on this little thing, and you might want to try to count, even this way if you want to. You can spread that out like this, and you can scroll on over. There's that first one, 23, and you see here, maybe that looks better. There's 23, 1, and you want to go 23.5, and then 24, 24 and a half, 24 to 25. Maybe you want to count that way. However you want to do it, right? But you can kind of get used to the software. Remember, you can click over here and you can scale it. And you probably want a little bit of better resolution. You should be able to get it like this. You can actually spread it out a little bit more by doing something like that down here at the bottom, or condensing it down. Okay. So what I just did is I hit this trial here, this individual measurement, and I'm going to look at counts. You can't do this on your file unless you have the full version of the software, which costs like $700. So we're trying to figure out if these online freeware will be sufficient. Now you see the red line is the raw value, and the black line is the one that we want to count. But you see, it missed all these. Every time it has a dot, it means it's counting it. But look here, it's probably going to be counting these maybe 3 times. What I can do is to decrease the standard deviation here off the mean, and then see that it's counting the events. So now it's coming in here and counting these, but we're missing these. So I need to drop this down a little bit more. Now we got the counts. So we got this one, this one, this one, this one. Missed that one. It's got this one and this one. And probably it should have got that, right? So now if I get that, I can do this. But look what it did here. Because the noise is more noisy, it's counting all of this noise in here. So you see this automated analysis is not working so well. Okay, so if I stretch this out a little bit, now I have to readjust the standard deviation again to kind of count these. And I don't want that, I don't want that, so now I change this again. And you see, you'd have to keep changing the automated analysis depending on how the waveform looks. And we can see that those are pretty clean, but now it's missed all these. So it's a real problem for doing it with an automated analysis across the line, because it's getting the large ones, but it's missing these, and if I get those, then I get all this noise that's in there. So this is the problem with using the software that comes with this program. What's nice here is that it will allow me, if it was a really smooth trial, to just count. Like right here, I could put my cursor at 23, come over here and say, okay, it's already counted 53 from before this time. And then I could go every half a second, for example, and then click here and see if the counts go up. You see, it hasn't changed. That number hasn't changed. It doesn't change until I'm over here where it starts to pick up these events. So, and then there's only like 3 events, but you can see there's many more than 3 events. So this is why by hand counting seems to be better than by automated analysis. There are some more comprehensible analysis where one can put little stars in there, but then again, you're doing it by hand. Okay, so I'm going to close out of this file. will ask if you want to save. Now the problem is, I think with the free software you don't have the ability to save anything that you do. So you might want to make sure that you write everything down on your analysis. Okay, so and then we'll assign these here in a little bit. Okay, so let me stop this echo. That was 30 minutes of echo, and